Has started, right? Okay, it has started now. Okay. Okay, so Bismillah ar-Rahman ar-Rahim. Uh, the other day on Thursday, we started talking about construction, and as part of the first half of the discussion, we had a look at snapshot diagrams, right? So if you recall, snapshot diagrams were used to basically, show the internal structure of an object at a runtime, and you can have different level of details. You can just show an object itself within a circle or an oval. You can even give details about its parameters, even values. We also had a look at mutable and immutable objects as well, right? As examples, we looked at string and string builder. So if you recall, string was what? Was a mutable or an immutable object?
Immutable.
Yes,
Immutable.
and string builder was
Mutable.
Mutable.
the mutable, exactly. So we had a look at this. We started talking about, so now we did start talk about why specification, but inshallah we'll use this as a starting point today again. So we'll inshallah now talk about why we need to have specifications, and then we'll talk about, the structure of this specification. And then inshallah, moving forward, then we'll talk about more details about, what are the different possibilities you can have as part of your specifications. So let's go straight to the why we need specifications, why they are important. Uh, the very first point, as discussed on Thursday towards the end of the last lecture, was that when you are integrating different pieces of code, usually you tend to have bugs, or your integration tends to be more fault prone. And the reason is that you can have a lot of potential of having misunderstandings between the behaviors of these two codes or different piece of codes you are trying to integrate. And the reason for this potential misunderstanding is that most of the time, every developer, every programmer, for sure has some specification in his mind. He understands, he has a clear logic, he understands that what are the input parameters I will pass on to this method, and what is the return value I will return back. But and what are the what kind of values I'm looking for this method to work, and so on and so forth. He has these things all the time in his mind, but if they are not written down, or not all the programmers actually write them down, hence the problem of potential misunderstanding arises, because since they are not written there, uh, you know, people can understand the piece of codes correctly or incorrectly, or they can have their own assumptions about, how this piece of code will work, what parameters I have need to pass, so on and so forth. And as a result, you can have these misunderstandings. And if you're going to have these misunderstandings, you are opening up a lot of potential for faults during the integration phase of a software application. And if you don't have these specifications written down, different programmers can have different understanding of them. People can have completely different expectations for the piece of code. One is referring to, so if you have one piece of code and you have different developers, and if you don't have any specifications, everybody can have his own expectations from that piece of code, which is again, you're calling for misunderstandings, hence you're calling for trouble. So, and then of course it becomes even more difficult if you don't have these specifications written down, because when the system will fail, when the program will fail, when you're going to have faults, it will be very hard to identify those faults. In other words, when you're going to have failures, it will be very hard for you to go on and identify why this failure happened, where is the fault. Because again, due to the lack of specifications, it's you will have to really go on and understand every piece of code and try to see what was expected, how we passed values, why we should not have done this. And again, if you have good specifications, it will allow you to move away from this blame game as such, because then you will be able to figure out why there was a fault. Because maybe the fault was because the client who is using your piece of code did not use it in the right way, or maybe he used in the right way, but there is a bug or there is a fault within the implementation itself. So that will help you isolate the potential reasons for your failures, and as a result you'll be able to better do debugging, fix the fault, and remove those failures from your application. Specifications again are good for the clients as well, because they basically spare them reading the code itself. So basically, from a client perspective, and of course here again by client I mean someone who's going to use your piece of code, someone who's going to use your method, who's going to use your class. So if you have specifications, it's a very nice for the clients, because they don't have to go on and read your code. They don't have to go through the difficult process of understanding how uh, you know uh, how we should should I use this method or not. Everybody's on board with me on this point?
Yes.
Great.
Yes, Dr. We are clear.
Alhamdulillah. So if just in case, I showed you this one the other day, we didn't discuss this, probably we stopped somewhere there. So in case you are not still convinced that reading specs are easier than reading the code, let's look at a uh, piece of code for an add method in big integer, implementation in Java 8. Are we able to make any sense of this out of this code?
No. Can't understand
Not at
anything
all.
about. Yeah.
Yeah, it's very hard. Yeah. Like we don't know even, what this signum is, right? What is the meaning of this compare magnitude is, what value I am inserting, right? What are the returns? So it's returning a new big integer. What is this result max, so on and so forth, right? It's a nightmare, isn't it?
Yes.
So if we only had code, we didn't have any specs, then of course we have to understand this big integer constructor. We have to make sense of these, what are exactly these compare magnitude, subtract, this trust, strip lead, zero int, and so on and so forth. Now, luckily, we have specifications. Are they much easier, clearer than the code?
Absolutely. Yeah. It's easier.
Absolutely, right? It tells you exactly what is happening here. It's saying you what? It's saying you have a big integer, you have an add method, you have to pass on, what are the parameters you need to pass on? You need to pass on value to be added to the big integer, right? And what's going to return you? It will return you that value plus the value you just added, right? So it's so clearer, it's more precise. So if I am a client who's going to use this big integer code, if I don't have these ones, then I can never figure this out easily, to be honest. And everybody will be understanding it in a different way and probably will be making a lot of mistakes. While looking at this clearer specification exactly tells me pass on a value, it will return a value plus original value plus the new value you added. So this is the strength of specification. This is the strength of having, specifications, because you're really making things clearer, precise, not up to interpretation. Now, of course, I just put this slide just so that when you come back and read this one, it's self-contained. So basically, specs of this big integer is straightforward for the client to understand. They are of course very human or readable, right? This was very human readable. One person can easily read it. No ambiguity there. This is a benefit of specification anyway, which is very clear usually to everyone. Now, what about this one?
I think it's true because
I think, Doctor, this way you will make the client interested only on the specifications, so that he will read the general idea, and you will do whatever you want in the background.
Exactly. This is the another benefit of specification, that as we just had a look here, if you are a client of this method, all you need to do is basically understand this and basically see, okay, I need to pass on this parameter and this value is guaranteed to me, right? You don't care about how this is being done. And similarly, from an implementation perspective, or a programmer perspective, you can achieve the same target the way you like. You can implement option. This could be one option of doing it. There could be another option of doing it. There could be a third option of doing it. You can go on and change them to improve the structure of your system, improve the performance of your system, whatever, and it does not impact anybody on the client side, right? So this is what I mean, that there are two benefits. This one usually is very obvious, that when we realize that specs are good because human readable documentation, I don't need to read the code. This is true from a client perspective, but yes, having specifications are also important and good for the implementer as well, because it gives them the freedom to change their implementation without really telling the clients, as long as they follow the specification, right? So, of course, specifications can make code faster too. What I really mean by this is basically, uh, you can uh, you can change the methods within it. You can go on and to change the algorithms without really affecting any other part. Now, what are the meaning of a weak specification? What I mean by this restriction on the inputs and so on and so forth. Uh, I'll talk about this very shortly, okay? And probably just remind me, inshallah, I'll come back to this slide too, especially for this one, okay? But let's move on first. So specification is more like a contract, okay? It's more like a contract. It's like it acts like a firewall, like a network firewall, right? Between the client and the implementer. And what it does two things. First of all, it shields the clients from the details of the working unit. So if you are a client of a piece of code, it shields you from inner details of the code. You don't need to read the code at all. As we just look at the big integer example, you don't need to read the code. All you have to do is follow the specification. This is, from a client perspective, this is what the firewall is doing. This is what the specs are helping us. On the other side of the implementer, it shields the implementer from details of the way other clients are using your unit. So you don't have to worry about who is using and how they are using. You don't need to know what are their plans to use it. You can only focus on making sure your code satisfies specifications. So as a result, when you use specifications, you are doing decoupling. But you're decoupling, you're allowing the code of the unit and the code of the client to be changed independently. So both sides can go on and change their code the way they like. So if I have, say, for example, this is the code which is being developed by the implementer, and you have a specs for it, and then you have a client who is using this piece of code, you are completely decoupling these two guys. They can go on, developers can go on and change the way they like, as long as they follow the specs. The client, can doesn't have to worry about it. And similarly on the other side, as long as the client is, following the specs, he can change whatever he likes. His code, both sides are completely decoupled. They don't need to really, worry about it, anything else. All they have to do is, both sides have to do is basically they have to respect the specification, which means they both have to obey their obligations. Okay. Now, when I'm saying they have to obey their obligation, what comes to your mind? What could be the obligations here for clients and developers?
They give the same input and output from the method as the specification.
Correct. So from a client perspective, you give the input as required by the specification, and from the developer perspective or the code implemented code perspective, you return the data you promised, something like this. So basically, this is your specification. It's acting like a firewall. Your client will input some values following the specs. He doesn't care about what's happening inside it. And then all he's guaranteed is that, based on its input, he's guaranteed a certain output. You can go on and change this one, the developer, doesn't matter. Clients can change the way they are using it, doesn't matter, as long as both obey the specification. And this is the biggest strength of having specification, in addition to be human readable and easy to understand and so on and so forth. Now, I think everybody's clear about this, right? It's very straightforward, right?
Yes, Dr. Clear.
Yes, yeah.
Alhamdulillah, alhamdulillah. Now let's look at an interesting example here, and this inshallah will also highlight the strength of having specifications and also the strength of having clearer specifications. Take a moment, it's a very easy piece of code. We have two implementations, two pieces of codes with us. Number one and number two. What's happening here? Of course, there are no specs given to you at the moment, so basically you're reading the code now. So what's happening in code number one?
In the first code, Doctor,
Yes, please.
it loops to search for a given value from the beginning till the end of the array, so that it will return the index of the first occurrence.
Great, great.
While on the second one, it starts from the
Yes,
end, so that it will return the last index.
great. Very simple, right? Very straightforward, right? Now, let's ask this question to ourselves. Are they the same or different? Are these codes same or different? Or are their behavior same or different?
They are different in
No.
behavior,
Mhm. Of
but
course, they're
same in
different
the
in code
spec.
anyway.
Yes,
They are,
yeah.
they are, they are different in a code anyway, right? It's very
Yes.
obvious, right? Now, about they are. Then you said something. Yeah, they are different in behavior, right,
In
or
behavior.
code?
Yes, yeah.
In
In
behavior.
behavior.
Okay, fair enough. So you're basically saying, we are saying here, they are different in code and they are also different in behavior, right?
Yes.
Now, uh,
Yes, Doctor. Can I
for
have your question, please?
yeah, go
Uh,
ahead, please.
for the output, it will be the same, right? Because the first code is ascending and the second one is descending, right? But the output is the same.
Exactly. No. So basically, Khalid is of an opinion that even their behavior is same, right? So we have possibilities here where we are saying that, of course, let's not forget about code, because code is different anyway. So from a behavior perspective, some of us believe that, they have the same behavior, while some of us are believing that, they have different behavior. Of
Uh,
course, we don't have any specs here. Yes, please go ahead.
I think they will have the same behavior in specific conditions. If the element are, if the target is not repeated. Otherwise,
So in other words,
the same.
yes. In other words, what you're saying here is that the value we're looking for in the array. So if I have an array like this, right? What will be the value returned by this method? Let's say I'm looking for 1. So my value is 1,
0.
It will be 0.
0. What about this? What about this one?
0 also.
0 also.
Right? So they are same in behavior from in this specific condition. But is it true all the time?
No.
No.
No. For example, right, if I have an array where I have, something like this, right? So this program will return what? If we're
Zero.
looking for 1, it will return 0. And this program will return what when we're looking for 1?
1.
1. Everybody's board on us here, right?
Yes.
Right. Everybody's on board with me, right here. Good, 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 good. Now, of course, as we said, all agreed. Code is completely different. You know, there are two different ways of doing the same thing. So they, in that sense, they are different, definitely. Now, we had a case where basically, you know, they were same or they have an equivalence behavior where basically when the array has only one across of the element, correct?
Yes.
And in that case, we can easily go on and substitute the method, the implementation without really impacting anything, correct?
Yes.
Right. Now, this is very good. Alhamdulillah, we figured all of that stuff out, right? Is there any other possibility we haven't thought about? So far we have thought about two possibilities. One possibility was that element only occurs one times in an array, right? This possibility, right?
Yeah.
Correct? And then we looked at
Yes.
this possibility where the element is being repeated. Is there any third possibility?
Doctor,
Yes.
Yahya mentioned a third possibility in the chat.
Oh, you did? Okay, let me follow the chat, sorry. So the third is Yahya said the return value is different if the target isn't found. Exactly, Yahya, absolutely spot on. Right? That what if I'm looking for value 5 now in this array? What will happen? What will be the return value by this piece of code?
It will return 3.
It will return the length of the array, right? And
Yes.
this method will return what? This method will return what? -1, correct?
Yes.
So see, in such a simple code, such simple examples, right? We can very clearly see that it depends on what parameters you input to it, right? And in one case, they have behavioral equivalence where basically when you basically go on and pass on an array with the same elements, while cases where you know you have repetitions, they have behaving differently. If you don't find an element in the array, they are also behaving differently there. So of course, we just observed it that of course they have different behaviors. When value is missing, you know, it will return different values, -1, so on and so forth, as Yahya pointed out. We also figured this one as well, that if your value appears twice, you know, the find first will give you the lower index, while the other one will give you the higher index, so on and so forth. But we also figured this out that, you know, when the value exactly happens only one time in an array, they actually both methods, both piece of codes have the same behavior. You know, they will return the same index. Now, this is something which is very obvious. This is the reason I'm giving all of these examples is just to build again a case here that why we need to have specifications and how we're using specifications. We can easily decouple the client from the implementation. So it may be that client never rely on the behavior in the other cases as well, right? For example, you know, if for example the client only needs to always going to use in such a way that you know there is only one element, then in that case, as an implementer, you can go on and implement the way you like, correct? You can implement it using find first or last, find last. Doesn't matter, right? Because the client in your application in that specific scenario is always gonna find one element in an array, right? So in that case, they are behavioral equivalents. You can substitute one piece with other. And you know, from a client perspective, you know, these two methods will be the same. We don't really care. Basically, you know, it's up to implementer the way he implements it. In other words, in a nutshell, the notion of equivalence, this behavioral equivalence, is in eye of the beholder, which is of course the client. So this everything is with respect to a client. If the client gonna pass on, always an array in which element will only occur once, then it doesn't care. It's just these two codes are behaviorally equivalent. The implementer can change them, select whichever he wants, and it will always work fine. But if the client is not looking for this, there is no guarantee like this, then you have to be careful about, you have to clearly specify what is the output you're going to give back to the client. Fair enough? Now, let's assume this is our specifications of the same code. Now, I'm not saying find first or find last. I'm only saying I have a method called find. Give me an array, give me the value you want to find, and I'll return you something. What's the precondition of this one? What is required? Or when this method will work fine based on this specification?
It requires that the value occurs exactly once in the array.
So exactly. So this is my requirement that, if you give me a value, sorry, an array in which the element only occurs once, what I will return you back?
The index.
The index. Now, if this is the specification, as a developer, do you have to write find first or find last, or you can use anything you like?
Anything I can use.
Exactly, you can use anything you like, isn't it? Everybody's on board with me here now, right?
Yes, Doctor, it's clear.
It's clear, alhamdulillah. It's not that difficult, but it's very, very important for us to have this clarity. So basically, if you look more formally, specification structure basically consists of several clauses. We have something called precondition, which is usually, we call them requires, right? And then you have postcondition, which we indicate by the word effects. So the guarantee of the specification is that if the client satisfies the precondition, the code will satisfy the postcondition. Now, what if the client does not satisfy the precondition? What will happen to the postcondition? Let's go back to the same example. So if the client, this is my precondition, and this is my postcondition. So if the client of this find method gives you an array where element only occurs once, he's guaranteed to be given an index, right? Now, what if he gives you an array where element occurs multiple times? What will happen to the postcondition?
You should you have two choices. You should handle it or return an error message or none, something like that.
Okay, Muhammad. That's okay. Right. So now let's go back to the point where I left. I said I'll come back to it, right? Now, the restriction on the input might allow the implementer to skip an expensive check that is no longer necessary and use a more efficient implementation, right? Now, if the precondition is not satisfied, as you said, as Muhammad said, he may have to go and check and see, whether the precondition is satisfied or not, right? And if it is not satisfied, he will throw an error or an exception, correct? But what is the real benefit of specification here is that you kind of avoid this, because if this is going to happen every time, then, why to satisfy a precondition? Why to put a precondition to begin with? Because if every time as a coder, I'm going to make sure that array is sorted or not, right? Or in this case, for example, I'm going to check and every time saying that, if the element only occurs once times in an array, if I'm going to check that before I'm going to return the index, I might as well, just handle it accordingly, right? So the strength of the specification here is that you are telling me as a client that give me this or satisfy my preconditions, I'll satisfy your post conditions. If you don't satisfy my precondition, it's unconstrained. I cannot guarantee whether you will get the right value or not. Now, the same example, let's say we're trying to find the element in an array. I don't satisfy the precondition, so I send them an array with element 1 being repeated. I'm not satisfying the precondition, correct? I'm looking for 1. Is there a possibility that I will get the correct result? Is there a possibility?
Yes.
When?
You have two answers here, two correct answers, but it's not unique. So you will not have consistency on the answers based on the coder implementation.
Exactly. So this is why it's unconstrained now. We cannot guarantee anything. No, it can be by chance, by luck that I get the correct answer. What will be the chance where I'll get the correct answer?
50%.
Yeah. But with implementation. Which implementation of the find will give me a correct answer?
Both of them should give you the correct answer.
No.
Find first, I guess.
Yeah, find first by chance will give me a correct answer, right? Because, it will give me 0 and by chance it's correct. But if I have implemented this as find last, I will get an incorrect answer, right?
Doctor, have you mentioned that you should return the first index?
This is the whole idea. That's what the point I'm trying to raise here is that if I have a specification like written like this, right? Then I'm actually forcing a thing here, right? So I'm saying precondition is give me an array where the element occurs once, right? If
Yes.
you do this to me, I guarantee you I will give you the index, right? Now, if you don't satisfy this, I have no binding on the effect now. I have no binding on the post condition now. You are lucky, maybe the way I implemented, you get the correct answer. Maybe you will not get the correct answer. There's no bounding now at all. Correct?
Yes.
That's the whole idea.
I have
So that's what I'm saying. Yes, go ahead, please.
Doctor, based on what have we decided that if I return 0, it will be considered as the correct answer? And if I return 1, it will be considered as a wrong return value?
Exactly. Now, this was purely based on the client's thinking, right? His expectation, something he has in his mind, right?
Yes.
So he's expecting that, I will get the correct answer. I'm looking for the first element and, I will get it, right?
Yes.
But that's not guaranteed, it's misunderstanding. This is the whole misunderstanding idea is, right? So this only works and this is guaranteed that, you have to follow the specs. This means you have to follow the preconditions. The program will guarantee you a post condition. If you don't follow the precondition, it's undefined, unconstrained. It can return anything. It could be correct, it could be incorrect.
Yes. Thank you, Doctor.
You're welcome. So basically, preconditions, a kind of obligation on the client, right? And or in other words, the one who is calling the method. And it's a condition over which the method is invoked. Post conditions are obligations on the implementer. So basically, as long as the preconditions are satisfied, they are supposed to give appropriate values back, or if they are supposed to throw an exception or some error message or whatever, they are supposed to fulfill this one. Now, the overall structure is a very logical implication. So if the precondition holds, as we have been discussing for the last few minutes, if the precondition holds, then the post condition must also hold. If the precondition does not hold, as I was giving you an example a few minutes ago, the implementation is not bounded by post condition. It's not supposed to return or behave the way the post condition is promising you, because if you don't fulfill the precondition, post condition is not bounded anymore. So in other words, it's free to do whatever. It can return you any value. It will return whatever, the implementation will do. It will throw some exception. There is no bounding on it at all. In other words, it's completely unconstrained. So if you don't satisfy the preconditions, it's unconstrained. If you satisfy the precondition, you're constrained to give you a correct output. And that's the strength of the implement of this specification. And now, as long as you satisfy the inputs, you don't care about how it's being done here. You're only concerned and guaranteed that your output will be given to you in a right way. So far, so good, guys.
Yes, Doctor, it's clear.
Good, alhamdulillah. Now, of course, I'm pretty sure you have seen specifications in Java. It's just they have some conventions there. They have these, parameter clauses, right? And then they have this return types and throws clauses. I'm pretty sure you guys have seen this. Usually, not usually, it's the case that you should put the precondition in your add param, right? Where possible, and your post conditions are written as part of your return and throws. So the same spec we just had a look a few minutes ago for finding an element in an array, where we said that the precondition is value occurs exactly once in an array, and post condition was you return an index of the value. If you have to do the same thing in Java, it will look something like this. Right? Now, do you have to understand the find method code? Do you really need to now know how it works?
No, Doctor, we don't need.
We don't need to.
No.
We are given the preconditions, we follow the preconditions, we are guaranteed a post condition. We also now very clearly know that if I'm not going to follow the precondition, I have no guarantee, it's unconstrained about the post condition. All right. Now, since because of these preconditions and post conditions and these specifications and clearer specifications, the client can use this find method the way they like, as long as they follow the preconditions. And the implementer can go on and implement this find method using find first or find last the way it likes, as long as it takes these preconditions. It assumes that this is the precondition, and then the values will be passed in this way, and it returns you the index of that array in this example. Now, this is the strength of these specifications, and this is really, really helpful in a large industrial setting where you have multiple developers, multiple team members across the different locations using each other's code, and you don't have to worry about reading someone else's code at all. Everybody's writing specs. They're telling you exactly the preconditions and post conditions. You carry on with that. You rely on these specs. Go and use them. Now, if an error occurs, is it easier now to find where the error is? Or what is the source of an error? Is it easier now with the specs? So, for example, if I am a client, this method find, and still an error occurred. So, what will be the things you will be checking first?
The preconditions, I think.
Exactly. So you will check the precondition. You say, did I satisfy the precondition for the method? And if the answer is no, then there is something wrong here, right? Because this return is only guaranteed for the preconditions. Now, if I have satisfied preconditions, then, and I'm still getting the wrong value, what it tells me?
The implementation is wrong.
Exactly. There's something wrong in the implementation. And that is a really, really useful, thing from a debugging perspective, because, without having this kind of well-structured specifications in a complex application, it will be, a huge, huge effort to even find faults and so on and so forth. Now, this brings us to another interesting example of just to help us understand that we can write specifications that describes a method which mutes an object, right? Remember we talked about the mutable and immutable objects, right? Mutable are the ones where you can change them, and immutable are the ones which they do not change themselves. So let's look at this example. Can somebody help me understand what this add all is doing? Of course, you don't have code, but alhamdulillah, you don't need to look at the code now. You have the specs. So I need your help here to help me understand as a client what this method will do.
Doctor, it concatenates list 2 to the end of list 1.
Yeah, so it concatenates list 2 the end of the list 1. When I can use or when I can expect this behavior?
If the two lists are not the same.
Exactly. So this is my precondition that the moment we say that if I'm going to pass on two lists to this add all method, and as long as these two lists are not same, I'm guaranteed that it will do what? It will do concatenation of list 2 at the end of list 1, and it will do another thing, if you notice.
It will return, yes.
Yes, which is this Boolean value. Right. So, is this true? I think we figured this out, right? So it's basically giving us two constraints, right? First, it tells us that list 1 will be modified, right? Because it will be appending list 2 at the end of list 1, right? And it will give us a return Boolean value. Now, this is what I mean by mutable method, that this method is muting something. What it is muting?
List 1.
List 1, exactly. Now, looking at the precondition, does it tell you something else? One is very obvious, it's very clearly written there that list 1 should not be equal to list 2.
Doctor, I think there is a one, but it's not mentioned, that the two lists have to be from the same type.
Okay, yeah, so they need to be of the same type. Yes, yes, true. Anything else you can detect or infer from their precondition?
Maybe different length.
Different length?
Yeah.
Now let me show you. Does it tell you this information, precondition?
Yes, it tells us because it says list 1 not equal to list 2.
Correct. And if I give a list 1 and list 2 equal, right? What is my expectation on the post condition now?
It's I cannot expect something in particular.
Exactly. Jazakumullah khair. This is what I wanted to hear. It's undefined, right? Because this is only guaranteed when this is satisfied. So if this is not satisfied, if I give a list 1 and list 2 exactly the same list, yes, it will concatenate, yeah, right? If you look at the implementation, for sure it will concatenate, right? Right? And since list 1 is changed, it will for sure maybe do a true here as well. But this is not what I expect. This is not expected from me. It's undefined. It's by chance it will be correct. By chance it will do it the right way. Maybe it will not do in the right way. There is no defined there. It's undefined, unconstrained. This behavior is only affected if you satisfy the precondition. I think this is very clear to everyone now, right? This is a very
Yes,
key
Doctor,
concept for us to understand. Yes, please.
I have a question.
Yes,
Regarding
sir.
this issue, can I have like situations and the effects? Like I have,
So can.
like for example, in this
Mhm.
method or in this spec, if I have like I have requires, but can I have another requires that is not like when things go wrong and the effect of it?
Yes, yes, yes. Now you can have multiple preconditions for sure, right? You can have multiple preconditions, and it's very evident from this example, by the way, that you can have multiple post conditions as well, right? In this case, we have two post conditions, right? So yes, you can have multiple preconditions, you can have multiple post conditions, and you can be as sophisticated as you can be or like to be with your preconditions and post conditions. Inshallah ta'ala, inshallah, I will show you a bit more interesting examples because this is just a starting and laying the foundation for us to understand the concept here, the fundamental concept. Uh, Inshallah, I'll show you some interesting examples on Tuesday where we'll see, that if we're clear with our specifications, what it really means, if we're unclear with our specifications, what it means, or if we deliberately are unclear, right? Because this is what I meant here. We can have weak specifications as well, right? So inshallah, I'll show you all of these possibilities very shortly, right?
Okay.
So in a nutshell, just because almost 10:50 now. So in a nutshell, we can just finish this one saying that of course, you have to use these preconditions and post conditions in a meaningful way. So basically, probably you will put this precondition because someone can argue with me why we need to put this precondition that list one is not equal to list two. Of course, the thing is, in practical terms, you may say that why people will like to concatenate two lists if they're exactly the same. So you can put all of these different conditions, uh, to define the behavior you want your programs to be doing. So I think it's 10:50 now. I think I'll stop it here, inshallah, and we use this as a starting point, inshallah ta'ala, on Tuesday. Let me stop the recording and take the attendance.